Okay, now we look at one of the minor methods. Uh, it it's similar to Bernoulli's, but a little bit different because it leads into Bernoulli's. What we've got here is something called Ricattis form of the differential equation, and here it is: dy dx equals p of x plus q of x times y plus r of x times y squared. That's the form of Ricattis. The form of the solution, and I'm going to give you all this, the form of the solution is y equal y sub 1 plus u, where y sub 1 is a particular solution, so you have to be given the particular solution. And u, what is u? U is a solution to a differential equation of this form. Well, if you look at that, that's Bernoulli's. So Ricattis leads to Bernoulli's. Bernoulli's leads to linear. So we could kill 3 birds with 1 stone, 3 methods with 1 problem. So I want to do one example. So I have dy dx equals 2x squared plus y over x minus 2y squared, and I'm given the particular solution y sub 1 equals x. So I want to get it, make sure I have it in this form. So p of x, as you see, is the 2x squared. Now q of x times the y, so in this case it'd be 1 over x. And then r of x is times the y squared, so if you look, that's a negative 2. So there we have our p of x, q of x, and r of x. So since I'm going to give you this formula, the u will be of the form du dx minus, so q of x is 1 over x plus 2 times y sub 1, which is x, times r of x, so that'd be times a minus 2, times u equals r of x, which is a minus 2, times u squared. So all I did was plug it into this form of the differential equation. So let's straighten it up a bit. Du dx. So I got a minus 4. So let's take it through. So I've got a plus negative 1 over x plus 4x times u equals minus 2u squared. So as I said, this is Bernoulli's. So w equals u this time, not a y, but u to the 1 minus n. N is 2 because of that 2. So u to the negative 1. So that's the same thing as u equals 1 over w. Again, the reason I'm doing that is therefore du equals negative 1 over w squared dw dx. And I'll make this a derivative. So I can take this differential equation now and put it in terms of w. So I've gone from x's and y's, now I've got x's and u's, now I'm going to have x's and w's. So this would be negative 1 over w squared dw dx, that's that, minus 1 over, plus negative 1 over x plus 4x times u, but u is 1 over w, equals minus 2, so this would be 1 over w squared. So when I multiply everything by a negative w squared, I get dw dx plus, and it's going to be a minus, so I'm going to put a minus there in front, negative 1 over x plus 4x. I already put the negative, w squared over w is w, negative a negative, so that makes it a positive 2, and the w squared of the w squared factor out. So now mu the integrating factor. So that would be e to the integral. Let me take that negative through. So that would be 1 over x minus 4x dx. So that would be e to the natural log of x minus 2x squared. So that e to the natural log of x, and I'm not even worrying about the positive anymore, but we're just going to assume it's positive, e to the minus 2x squared. So that would be x times e to the minus 2x squared. So that's my integrating factor. So this problem becomes, all the way over here, the total differential of the unknown function, which in this case is w, times the integrating factor, x e to the minus 2x squared. What do I have on the other side? So I'll have 2 times x e to the minus 2x squared dx. So integrate both sides. So w times x e to the minus 2x squared. How do I integrate? Well, look, that's nice because I put a 4 there, a minus 4, and so I have a minus 1/4. So this would be minus 1/2 e to the minus 2x squared plus c. So that's what I've got. Let's take the w. The w is 1 over u. Now let's divide everything by x times e to the minus 2x squared. So what do I get? I get 1 over u equal to, well, I'm going to get minus 1 over 2x plus c over x. It being over a negative exponent brings that 2 to the top, e to the 2x squared. So what do I have here? So basically u equals, and I'm going to put it in brackets, minus 1 over 2x plus c times e to the 2x squared over x, all raised to the negative 1. So that's my u. So therefore, my solution, again, is y1. y1 was, in this case, x plus this u. And there we bring it down. So that is my solution. And it doesn't look nice, but that's my solution. That's Ricattis. Not quite as important as some of the other ones, but it did lead to Bernoulli's, which led to linear. So we have 3 methods in one.